Square root of 4 over 25 can be written as square root of 4 over square root of 25. And then we can simplify the numerator and the denominator separately. And so we'll have square root of 4 is 2. Okay, no more square root, so we'll put here 2 over 5. Here we'll have negative square root of 5 on the top and square root of 36 at the bottom. Square root of 5 cannot be simplified anymore, so we'll have negative square root of 5 over square root of 36 is 6. Now we can put the negative on the square root of 5, or we can put it in the middle. So let's fix this. We can put the negative right here. So here we can rewrite this as cube root of 1 over cube root of 27. Then cube root of 1 is 1. Cube root of 27 is 3. Okay, 4. We have here cube root of negative 7 over 8. So when a fraction is negative, we can rewrite it as negative 7 over 8. So have the negative in the top. Or you can also write it as 7 over negative 8. Okay, now because negative 8 is a perfect cube, so we are going to put the negative with the 8 so that it is convenient to find the cube root of this. So here we'll have on the top cube root of 7 over cube root of negative 8. Now 7 is not a perfect cube, so we'll just keep it as cube root of 7 because it can't be broken down either. And the cube root of negative 8 is negative 2. Okay, number 5, we'll have square root of 3 times square root of 12. We can multiply the 2 together, so we'll have 3 times 12 inside the square root, and that's going to give us 36. The square root of 36 is 6. In number 6, we are asked to multiply square root of negative 2, which is not defined. We cannot get a square root of a negative number. So this does not exist. The answer to this does not exist. And the answer to this guy also does not exist. Therefore, we cannot multiply the 2, and the answer does not exist. Okay, number 7. We have here cube root of negative 2. Because this is cube root, we can have a negative radicand for a cube root. Because when we multiply a number by itself 3 times, it is possible that you have 3 negative identical factors. And so the product will also be negative. So cube root of negative 2 exists and cube root of negative 16 exists. Therefore, we can multiply these two radical expressions. We can have cube root of negative 2 times negative 16 is positive 32. Then we'll have to simplify this. We'll have cube root of 2 times 2 times 2 times 2 times 2. This is 32. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Then we're going to look for 3 identical factors. because if we have three identical factors such as this, 2 times 2 times 2, that's going to give us 8, and the cube root of 8 is 2. But 2 times 2, there's not enough. We only have 2 identical factors, so we need 3. So we can't get that out of the cube root, so we'll keep it inside the cube root. So we'll have here cube root of 2 times 2 is 4. Okay, in number 8, you have a cube root. Then inside the cube root, we have square root of 4 times square root of 16. So we'll simplify the expression inside the cube root first. Square root of 4 is 2 times, and the square root of 16 is 4. And then now we'll have cube root of 8. And the cube root of 8 is 2. Okay, for number 9, we have square root of, and then inside the square root, we have cube root times cube root. Okay, so we will simplify the expression inside the square root first. So cube root of negative 54 times cube root of negative 4 is going to be cube root of negative 54 times 4. We can just write it as negative 54 times 4, negative 4, or simply 54 times 4, because negative times negative becomes positive. And then we can break it down. So instead of 54, okay, so if we do 54, what are the factors of 54? We know it's going to be 2 times 27, and then 27 is 3 times 9, and 9 is 3 times 3. So therefore, 54 is 2 times 3 times 3 times 3. So we're going to put here 2 times 3 times 3 times 3. This is for 54. And then for 4, that is 2 times 2. Okay, so this is, let me just change this. All right, so now we can simplify the cube root. So because here inside the square root, we have cube root of these factors. We need to look for 3 identical factors. So I have a 2 here, another 2 here, and another 2. So I have 3 identical factors of 2. Cube root of that is 2. So I'm going to copy the square root, and then I'm going to get the cube root of 2 times 2 times 2, which is 2, times, then the cube root of 3 times 3 times 3. So 3 times 3 times 3, that we know that that's 27. The cube root of 27 is 3. So now we'll have square root of 2 times 3, and that's going to be square root of 6. Okay, so let's erase this. So here we'll have square root of 16 over 5. We can rewrite it as square root of 16 over square root of 5. Square root of 16 is 4, but square root of 5 is still square root of 5. We can't simplify this anymore. However, we cannot have a square root at the bottom. Okay, so mathematicians, they want to simplify expressions, and if there's a radical or a square root at the denominator, it is considered not simplified. So what we do is we rationalize. To rationalize means you want the denominator not to be in square root, but we don't want to change the value of this fraction. We do not change the value of a fraction when you multiply it by 1, because any number multiplied by 1 is still the same as the number. Like, for example, 10 times 1 is still 10, 5 times 1 is still 5. So I'm going to multiply 4 over square root of 5 by 1, but 1 could be expressed as square root of 5 over square root of 5. This is also 1. And what happens is when I do this, I'm going to get 4 times square root of 5 is 4 square root of 5. And square root of 5 times square root of 5 is square root of 25. And then this becomes 4 square root of 5 over square root of 25 is equal to 5. So no more radical at the bottom. It's okay to have a radical on the top, but not at the denominator. So now this is the same as this, but we don't have a radical at the bottom. Okay, number 11. Number 11 will have square root of 5 over square root of 3. Square root of 5 cannot be simplified anymore. Square root of 3 cannot be simplified either. So the only thing that we need to do here is to make sure that there's no square root at the denominator. So we need to rationalize. Okay, so to rationalize, we multiply again by 1 so that the value doesn't change, but 1 could be in the form square root of 3 over square root of 3. So notice that I am choosing an expression that is the same as the denominator. So denominator over denominator, that gives me 1. 1 times square root of 5 over square root of 3 is still square root of 5 over square root of 3. So now this becomes square root of 5 times square root of 3 is square root of 15 over square root of 3 times square root of 3 is square root of 9. And then we'll have square root of 15 over square root of 9 is 3. That's the final answer. Okay, number 12. Cube root of 27 over 2 can be expressed as cube root of 27 over cube root of 2. Now, cube root of 27 is 3, but cube root of 2 we cannot simplify any further, so we'll just keep it cube root of 2. However, we don't want the cube root at the bottom, so we need to rationalize this. So we're going to multiply this by something so that by something equal to 1, but at the same time, it should get rid of the cube root at the bottom. Now we have to remember that when we're getting the cube root, we are going to look for 3 identical factors. Here I have 2, which is a prime number. So in order for me to be able to get rid of that cube root, I need to have 3 2's. So when I do this, when I rationalize, I will rationalize by cube root of 2 times 2 over cube root of 2 times 2. So now if we multiply the denominators, we notice that there are 3 2's. And so we will be able to get the cube root of the 3 2's, and therefore the cube root disappears in the denominator. So here for the final answer, we'll have on the top, we have 3 cube root of 4 over 3 over cube root of 8, which is 2. So there's no more cube root at the bottom. So again, I forgot the 3 here. So 3 cube root of 4 over 2. Okay, so number 13, we'll have, this is the same as square root of 12 over square root of 8. Before we do that, maybe we can reduce this to lowest term first. Notice that 12 and 8 are both divisible by 4. So we can divide this by 4. So divide by 4 and divide by 4. So we're going to have square root of 12 divided by 4 is 3 over 8 divided by 4 is 2. Okay, so now we can separate the numerator and the denominator. So square root of 3 over square root of 2, or put them in their own square roots. Now there's a radical at the bottom, there's a square root at the bottom, so we are going to multiply this by 1. So times square root of 2 over square root of 2. And this is going to give us square root of 3 times 2 is 6, square root of 6 over square root of 2 times square root of 2 is simply 2. Okay, for this one, we'll have, 3/4 cannot be simplified anymore, so we'll just have cube root of 3 over cube root of 4. And I can rewrite 4 as 2 times 2. So now we notice that at the bottom, we already have 2 identical factors. So in order to rationalize, we are going to use cube root of 2. We only need one more 2 to be able to rationalize the denominator. So we're just going to use cube root of 2 over 2. All right, so now we are going to have cube root of 3 times cube root of 2. That's going to be cube root of 6 over cube root of 2 times 2 times 2 is going to give us 2. Okay, number 15. So we have here cube root of 2 over cube root of 3. So it's cube root, times cube root of 4 over cube root of 9. Now this is equal to cube root of 2 times 4 is 8 over, at the bottom, cube root of 3 times 9 is 27. Okay, and therefore we'll have cube root of 8 is 2 over cube root of 27 is 3.